Hi, I'm Andrew Steinacher and with Wolfram Research, and I'm going to be presenting automotive data analysis, where I've tracked some information in my car for a couple of years now, and have some neat information to show. I guess I'll go ahead and get started then. My name's Andrew Steinacher. Normally I work on the food and nutrition content in the Wolfram language, but today I'm going to be talking about a data science project that I've been working on for a couple of years now, sort of on and off as a side project. So if things are not as polished as you might hope them to be, it's because I didn't have a lot of time to really do it when I first started working on it. But anyways, moving forward, I'm going to be talking about some automotive data analysis. This giant paragraph of text here basically kind of explains it, but it's probably easier to just look at the outline. It's probably a lot more simple. Basically, I started by collecting gas mileage information in my car in kind of a low-tech way using web forms in the Wolfram cloud. And that wasn't really enough for me. I was really interested in going further, so I looked into analyzing traffic on my car's CAN bus. More details on that later. And then eventually I made a user interface to be able to help me analyze that stuff better. And I created an EntityStore to do that stuff. And then I sort of aligned to some GPS information that I have from my phone and that sort of stuff. So really quick and dirty, that's kind of how things go. So a couple years ago, like I mentioned, I created a web form that allowed me to, when I would get gas in my car, basically punch in the numbers that are on the receipt and keep track of how much gas I used, how much it cost, and that sort of thing. And then attach it to an automated report system in the cloud. So there's a link there and a QR code if you're interested. And it's been interesting. There's some neat stuff to notice, like it gets really, when it's cold outside, if I can find my cursor here, gas mileage is significantly worse. I let the car warm up a lot longer because it's better on the components and stuff. Some neat stuff with the prices, like a huge drop right at the beginning of the year. So there's a couple neat things that I found in that. But I really wasn't satisfied with that level of detail, because sometimes it could be like 2 weeks or something like that before I would get gas. And I really wanted to get more information from there. And there was a display in my car that shows the instantaneous gas mileage and the average and that sort of stuff. And I really wondered, how can I tap into that and actually go further? So I did just that. After lots of rabbit hole searching and stuff like that and learning, I learned how to sniff the traffic on the CAN bus, which is the little port that you can use to troubleshoot problems in your car. And so basically, in a nutshell, I've learned quite a bit about it, but kind of to boil it down, more or less it's a bus standard that basically is 2 wires that are attached to every controller in the car. And so as you can imagine, a modern car has lots and lots of parts that all need to be connected. Some parts need to be connected to others, some to many. It's kind of hard to run all those wires. So they came up with a system that's about as old as Mathematica, that is just 2 wires and a communication protocol, so that you don't need to have a host or anything like that to communicate things. So it's a fairly simple thing, at least conceptually speaking. And so more or less, this is what the structure kind of looks like. More or less, there's like 8 bytes of data, or up to 8 bytes of data, and then about almost 4 bytes of an ID that describes who's sending it, what it's for, and that sort of stuff. And then there's some nice things with it too, like the priorities. Like for the steering wheel are going to be much more important than the fan speed that you have in the cabin or something like that for the comfort of the driver. So the lower IDs are prioritized more and that sort of thing. It's also nice and stable, so that if you send something and nobody gets it, you can just keep sending it. And so then other devices will ACK or acknowledge when they've actually gotten the information from there. So it's a fairly simple thing. Basically, in a nutshell, all you really need to get from this is there's basically 12 bytes of important information, 4 for the ID and up to 8 for the actual data itself. So how did I do this? Well, if you want to do this too, you're probably going to need to have some parts. Most importantly is probably a microcontroller of some kind. I myself just use an Arduino Uno. You're going to need some way to interface with the CAN itself. I've seen people make circuits themselves. I'm not that good, so I just use a shield. And I also have another shield to be able to keep track of the time and store things in the SD card. So this is sort of the completed sandwich, if you want to think of it that way. So it's sort of plug and play, since I'm not as strong on hardware as I am on software. Some other notes with this too. You're going to need some cables, obviously a connection from the OBD2 port to the DB9 that's on the thing. on the actual can shield itself. You'll need some power to it, and for speed reasons, I've attached a wire from the square wave on the RTC into an interrupt, so I can just count the number of seconds since it started up. It's much smaller and faster that way, as we'll see in a minute. And for safety reasons, I've done some other things like removing some resistors that are optional, since they already exist, and I've put on silent mode in the library I use because I don't really want to send any data in a moving car. I don't really trust that so much, so I've done everything that I can to make it as passive as possible so that I just listen. And so I get a lot of information back, and so I kind of fought with the format at first of how I wanted to store it. And my original idea, just to get things together, was to do, the hour, minute, second, and then, the ID, and then, all of the information from the data there. But it turns out that's really large and really slow to do everything in plain text. So with a little bit of work, here's some, C code that you can kind of see here. Basically, I store it all in a struct, and I keep track of just the number of seconds, and then I just store the ID and the actual data directly there. And so it's much smaller. It's only 14 bytes as opposed to when I was using about 40 before, which is a big difference when you're talking about really fast systems. So more or less how I read it into the Wolfram language, I've got this nice little format that allows me to ingest all that. And just real quick, I'll run this real fast here. This one file, which is about a 10-minute car ride, still gives me about 500,000 points. So it's pretty intense as far as that. And basically, when I first got started, this is basically all I had. I had the time. This is the seconds, so 2 seconds, 3 seconds, and 4 seconds after start. And then these are the can IDs. And then basically the raw data, just a bunch of numbers. And that's basically all I had. I didn't really have anything else to go on. There's really no manual to reverse engineering your car, so as you might imagine, there's a lot of experimentation and research and stuff like that to go hunt down what it all means. But if you do find things, it actually produces some neat, useful information. So for example here, I haven't shown the details how I get it into a time series and that sort of stuff, but if you pull out a specific ID, and you pick out a specific byte, you can actually plot out something useful. Like this is the temperature. I believe it's the engine temperature. The scale factors, of course, are not right there. But anyways, this manual stuff was kind of painful to do, to ingest the file, poke around at it. And once I had gotten basically the rough understanding, I needed a way to go faster. So I found it was easier to just build a GUI with dynamic module, which I'll show here. I learned a lot from Lou's talks, highly recommend seeing his stuff. And of course, this isn't the most beautiful interface in the world, but it works pretty well. So I've been able to, based on the file name, encode what day and minute things started. And then from there, I just use the counter of the seconds to be able to keep track of stuff. That way it keeps everything small and simple and easy to handle that way. So we just choose a day. Maybe we'll just choose Pi Day. We can select a different data plot here. So this is the start times column, the end times column. And then all of this stuff here is stuff that I've found in the car's information. So like if I look at, say, the accelerator pedal, for example, you can see there's a nice little display for it, in addition to some other stuff like how often each can ID is sent as well. So for example, that's the accelerator pedal. Probably more interesting is the speedometer, perhaps. You can kind of see where I stop, and I get up to about 45 or so, something like that. And it's kind of useful that way. But of course, the thing I was most interested in was grabbing the fuel flow, which I can get here. And you may go, wow, how did you know what the units were? Well, after a lot of research and poking around, I found those. And it takes a little bit, and there's a lot of tools involved that I had to make to be able to combine bytes together in the right way and attach the right factors that I had to look up and find. And then you may go, well, are those factors correct? And we'll see that in a little bit here too, that we can verify that at least for sure this one is correct as well. But the idea here is with this interface here is that you can punch in IDs, you can give them names, you can change the actual Wolfram language code that's used here. Like for example, I have, I think I called it fuel economy. I can use Wolfram language code here to clip everything so that, when I'm coasting, I don't get 1,000,000 miles to the gallon showing up. So it makes things a little easier to see on a plot this way. from there. But anyways, I can add other options and stuff like that into it. It's been pretty nice to be able to customize it and poke through and compare different trips and that sort of stuff, and load it dynamically and play with various things as I go and hunt down where the information has come from and all that. So anyways, that's kind of the idea there. One last thing I'll point out too is that it's also been nice to look at the actual message space itself, where certain things live. I know this doesn't really look super great, but I also want it to be big enough so you can see it. But I found temperatures, all individual wheel speeds, all are on this one ID here, and that sort of thing. So there's a lot of cool stuff there that I've been able to build using this information. I've been able to hunt down with the interface, which is kind of nice. Yeah.
What's the meaning of on a particular row, what's the meaning of the spaces and just like that, how many bits you have to go over to find the information?
Right, so this is sort of grouped by byte. So across here, these bigger sections are byte numbers. So this is byte 1, byte 2, byte 3. People who are familiar with lower level languages probably don't like that I chose 1, but Wolfram language slot 0 is a different meaning. So, but yeah, these are the bytes, and the bit numbers are also there too. Sometimes these things aren't always done in terms of, you know, individual bytes. I haven't found anything that's been super useful that doesn't line up with bytes yet, but yeah. Right, yeah, and so the wheels, for example, all live, the individual speeds live on one row or for one message, so that's for like D4, for example. So a lot of these things are sort of packed together so that they're meaningful to various systems.
You look to see if you ever got your wheels going at significantly different speeds?
You do around corners. I mean, maybe not significantly, but there's definitely a difference. It's pretty interesting. One time, it's too bad I wasn't recording, I was driving through some ice and definitely spun the wheels a lot. It's an all-wheel drive vehicle, so it's not quite so impressive. But it would have been nice to see that information and go back and go, wow, look what really happened. But haven't driven through some ice yet to really see that. Yeah, maybe tomorrow. Maybe tomorrow. From what I hear, the weather is pretty bad. So anyways, that's kind of the tool I used and was able to you know, poke around at various things that way. And that was kind of nice in some sense, because I could zoom in on particular trips, and if I could remember, oh, on this day, on this trip, you know, I did this or I did that, and I could kind of hunt things down. But if I want to do more than that, like plotting multiple things, it's kind of hard to do. Of course, I guess I didn't really show it here, but some of the niceties that I've put in is like a copy button, so that I can, you know, paste it and get out a time series object. And if I do that for a couple of days, I could manually, you know, put together you know, a dateless plot that has them all on there and that kind of stuff. But that gets a little tricky and it's kind of manual. And around that time, I was actually looking into aligning to some GPS data, and I really did not know how to really tie that into the interface without, you know, rewriting it significantly. So in order to avoid that, I started to think, how am I going to do this? How am I going to keep track of this? How do I know how to group trips? And then it dawned on me one day, I thought, well, why not just make the trips entities and build an entity store? So I did that, and it's really nice because now I can actually filter my trips with implicit entity class syntax. And you know, since I've accumulated about 20 gigabytes of data now, it's not so easy to just import it all. That doesn't really work for very many of them. So instead, I just only load the core metadata from all these, you know, based on the file name, which has the date stamp on it, and then I can get, you know, a reference to the file where all the other information lives. And from the CAN GUI interface that I had made before, I can actually extract other information and make actual nice time series objects with units, as we saw in Eric's talk just before this, based on all of that exploration I did. And from there, entities, it's really easy to add more properties and that sort of stuff to be able to align to things. So I won't run it here because it takes a minute for it to run, but this is basically the code in right here, where basically the code just takes a directory where I have all 20 gigabytes of data, a directory that has the plot choices, as I call them. That's all the stuff I found in the CAN GUI stuff. And then a data bin where I've been dumping every 10 seconds my GPS position when I'm connected to the Bluetooth in my car. More on that later. But again, I've registered it. Now I've got this nice trip entity type loaded in. And just so I don't have to run this either, since it'll probably take a while to get the GPS information. But these are some of the properties I have: the date, how long it is, you know, start and end positions even, dates, times, the reference to the file, and that sort of thing. And if I have multiple trips in a day, the trip number's also there, baked into the canonical name. And so this allows me to do some nice things and plot things together more nicely, like the gas and the brakes, for example. You can see that the relationship there. The scales are kind of off there, but you can still kind of see it. And so I got into a little more, and I won't really run this too much. Basically, I've got the ability to pull out the fuel flow time series. And from there, I wondered, in order to check if the scale factors are actually right on the fuel flow, how can I verify that? And one way to do it is to actually just integrate the fuel flow. So I wrote a little piece of code that I may eventually put on the function repository that more or less integrates the time series. And so when you do that for a single trip, for example, you get a reasonable number out, like 0.18 gallons, which isn't so it doesn't seem so far off. So I thought I would check it, and so I can. And if you do map this over the whole thing for a period of time that I had been using before with my low-tech web form, I wound up with about 12 gallons. And I thought, well, 12 gallons is actually not too far off from my tank size. It's about 14 gallons, and I don't all the way go to the bottom, So I checked it, and if I compared to it, it's actually pretty close. I get about 12.3 gallons, so it's a little less than what I'm getting there, but for the most part, that's pretty close. So I did it on a larger scale, and just with a simple scatter plot, in a perfect world, this would, if they were exactly aligned with each other, they would be a nice, perfectly straight line with a slope of 1, but it's not quite there. And you can see there's some outliers. Sometimes I can't have it plugged in, and so there's less fuel being used according to what the Arduino sees and what the receipt sees, so to speak. So that's why there's some things that are off. Sometimes it's the other way. There's a couple outliers there, but I should probably find anomalies here to rip those out and check that the slope is better. But getting a slope of about 0.89 is not too bad. So it agrees pretty well. Maybe I can change that factor now. Yeah. Well, see, yeah, it definitely varies a lot there too, but again, this is only interested in just how much fuel I use. So yeah, there's probably some variation there too that needs to be taken into account. I have not yet quite found out the slope of the car. I don't know if that's reported on there, but keeping my eye out for it to see if that makes a difference, yeah. Yeah, in Champaign it would be very flat, that's true. So there's some other neat things I've been able to do is look at my fuel economy, over the course of a year, or grouping by month regardless of year and that sort of thing. I had originally thought that my gas mileage would be higher in the summer months and stuff like that, but I guess my air conditioner does more damage than I realized to that. And so it actually increases quite a bit in September and October. It takes a big nosedive in November and December when it gets cold, and I have to let it warm up longer and that sort of stuff from there. But anyways, I won't spend a lot of time on that. Going a little further, I'll talk a little more about the GPS data that I've put in. So basically, I had the idea, boy, it'd be nice to know in order to plan this stuff out. If I knew where the car was, I might be able to know where the steering wheel is, or when I go fastest, or maybe even find some cooler things like how long I spend at intersections and stuff like that. So I just installed a little app on my phone rather than learn Android programming from scratch, since I'm not as familiar with that, and I didn't have a lot of time to learn that, even though I want to. I haven't had a lot of time to do it, so I used an automation app called MacroDroid, but pretty much every automation app out there is probably able to do it without much effort. And so I just used the Bluetooth connection whenever it triggers that I'm connected to the car. Then it just every 10 seconds just logs my location, speed, and accuracy, and the time that's associated with that position as well. And so as an example trip, I know this is a little small here. We'll get a zoomed in one, but you can see here, this is Wolfram, so we're probably right over here now. But this is the Wolfram parking lot, and so you can see I went over and I made a turn, and I stopped at a couple stoplights here and that sort of thing, and worked my way up towards a busy area of town that way. The red, which is kind of hard to see, maybe if I just jump to the next slide, it's easier. The red dots are the accuracy, so that's the accuracy to which the position is there. The center of it, of course, is the position that's reported, and the blue dots are just there as a guide, so you can kind of see what they are. But I have nice little tooltips that kind of show the time, the position, and the speed as well, which I haven't really incorporated into this particular plot. But as you can see, when you look at the roads, the red is actually much wider than the lanes sometimes are, so it's not really good enough to do like lane level expertise, accuracy, you know, to say, oh, I spend more time in the right lane than the left lane. So basically I have to do, you know, if I'm going to know which direction I'm facing, I have to use context, when was the previous point and that kind of stuff. But it's good enough to get an idea of where things are and kind of where I've been. So basically for a long time I've been collecting these points, probably more substantially in the past several months when I switched to actually being able to do it once I'd figured it out every so often. But I've basically got about 70,000 points in there, so over the course of almost a year in total. Most of my time has been spent in Champaign because I used to live here, and then about half of the time I moved to Fort Wayne and I visit family in Indianapolis. So, I guess I should go show a little more of this. There's some gaps here when I was experimenting with things. It looks like most of my trips are on the weekend as opposed to during the week, and that's kind of nice time distribution as well. If you look at all of the data where all I've been, this is kind of where it is to give you an idea kind of where it is. Of course, here we are in Champaign. That's where about half the time is spent, about 20,000 points there. Almost 20,000 points in Fort Wayne as well, where I moved to. And I've taken many trips around to visit family and other things, and you can see that I went down this way, and apparently I just don't have any data around Terre Haute. I guess either my phone died or the GPS signal's not super great there. I'm not sure. But it is interesting to see that. Another thing I looked into was when I'm under 15 miles an hour where I'm basically stopped. And it's interesting that, you know, the destination cities that I've been to, you know, is where you'd expect to see that. But I also see a lot of stuff with, let's see if I can find my cursor, with interstates as well, where there's been construction and other things like that on, say, 74 or 69 and various roads there. So it's kind of nice to be able to see where these things happen. It'd be neat to zoom in a little further on those areas on interstates and find out where exactly the construction was and other things that way. Of course, if we zoom in even further, it gets a little more interesting. So this is a map of Champaign. I've sort of anonymized the data a little bit and tried to avoid obvious places where I spend a ton of time, like in the Wolfram parking lot, for example, where I would, you know, it would be very blue there and everything else would be basically flat. So I tried to remove some of those. But you can see definitely some intersections are very bad with stuff. But definitely I've been kind of in all over and over the course of, you know, almost a year in Champaign. Another neat thing too is if you look at just the times when I'm less than 15 miles an hour, you can really see my commute coming into play where that one intersection is really bad. I think there's a stop sign here, you know, an intersection here, you know, where I spend a lot of time that way. To go a little further though, it's a little different in Fort Wayne. It's not on a nice grid. Things are a little more, you know, moved around, so hexagons make a little more sense here. But definitely there's a lot of traffic areas as you go deeper into the center of town and stuff like that. The stopped areas, this intersection's pretty bad. I think there's a grocery store up here, which is probably why that one's so intense there. But it is kind of neat to look at and see where I've been and, you know, how it goes. Indianapolis, similar story there. It's not quite as clear and everything. But in the last little bit, I did a little fun thing where I found out where I parked in the Wolfram parking lot. And I only have about 118 points there, so it's not like super great, but it's kind of more of a fun thing to kind of look at. So for reference, we are in here. So catty-cornered across the street is where the parking lot is. And so all the little dots there kind of show where I've parked. If we zoom in a little closer to kind of see what's going on, if you change the grid size to be around the size of a parking spot, you can kind of see where I've parked and where I choose to park. Obviously, I don't leave my car in the aisle or anything like that, so it probably should be skewed a little bit more towards this side. I don't think I ever parked in the grass. I'm pretty confident I didn't park over here, and I'm pretty confident I didn't park at Jarling's either. I'd be tempted to get the frozen custard there. But it is a nice use to be able to kind of see things that way. So more of a fun gimmicky thing than anything else that way. But so yeah, so that kind of wraps things up there on what I've done. Some things I do want to do, I'd like to be able to detect who's driving. There's a couple ways to do that. One is if I have whoever else is driving install the same automation app on their phone, then I can just have the data bin with an extra field in it to be able to tell where, you know, who it is and that sort of stuff. It'd also be nice if I could hook up a Wi-Fi chip to it so that I could keep a hotspot on my phone and then, every couple seconds or something, upload to the cloud and dump things into a data bin there with, a smaller set of data, not the whole thing. I wouldn't be able to squeeze in everything to it. But, some of the things I'm more interested in speed, gas mileage, that kind of stuff. I'd also like to get into, live streaming the data onto a screen so that I can interactively, do things. Rather than like how I found the doors, where I had to just remember which doors I opened and closed, and then open and close them and shut them like 5 or 10 times in a particular order so that I could go back through the data and hunt it down. Some other things I want to do is like dead reckoning and odometry and some path analysis stuff. It's kind of messy there, but I'm working on it, and aligning with the GPS data is really helpful there to be able to piece that kind of stuff together. So I guess I'm out of time here, but that's more or less it. So thanks.